Okay, exam 3, practice, question 1. I give you a trinomial. I don't give you the middle number. I asked you to tell me what the signs could be, what the pairs are, and then what numbers could be in the middle. What are the possible middle numbers? So the first step is to tell me what the signs are. This last number is negative, so I know the signs are different. I also know that the first one would be negative. I mean, you can put plus minus, but I like to put this one first. Now I have to list the pairs of numbers whose product is 12. So 1 and 12, 2 and 6. 12 is divisible by 3. 12 is not divisible by 5. And 6 I already have. Once you get a repeat, you have them all. You know that these are the only 3 pairs of numbers whose product is 12. Now, that's not all I asked you. This is what a lot of you showed me when I asked you to look at the problems. You just wrote the pairs down, but I want to know the number that could be in the middle. What goes there? So you can do 2 things with the pairs. You can add them or you can subtract them. If the signs are the same, if this was minus minus, you would add these pairs together, right? You put a 13 here and 8 here, but the signs are different. When the signs are different, I subtract. So you're going to do 12 minus 1, 6 minus 2, and 4 minus 3. So the numbers in the middle could be 11, 4, or 1. This is what I'm asking for. If you don't tell me the numbers, I don't want a particular one. You know, I don't want you to pick one and say, oh, what's in the middle? You don't know. I asked you for the possible middle numbers, and it's those 3. Don't pick one and say, oh, it's 11. You have no way of knowing it's 11. You don't know that. I'm just telling you what could be in the middle. All right, question 2. I haven't asked you anything similar to this before. This is the first time you're seeing this one. So it could be a little tricky the first time you ever do it. Now, I want you to first, there's a few approaches to this, but I think the easiest one is to understand that you should try to build the thing as if you were going to factor it, right? I know that, the signs are different, and I know the first one should be negative. Now, remember what I always said to you. The bigger number has to go here, and that's the whole key to this. That, if you were going to pick 1 and 18, the 18 would have to go here and the 1 would have to go there. So I think you can see right off the bat that this can't happen. If you had 18, the one that would go with it would be this one. And the larger number, right? 18 take away 1 is a positive 17. So this choice can't work. So your best bet here, right, is to go through and figure out who has to go with this one. Now, what would go with 3? You'd have to have 6, right? 6 and 3 make 18. But a positive 6 take away 3 is not negative. So this is out. Which one goes with x minus 2? Well, that would have to be x plus 9, right? 9 and 2 make 18, right? The signs are different. But 9 minus 2 is 7. Look, I have the same friggin' one here. Same thing. 9 take away 2 is not negative. So you just eliminated 2 of the choices. So by default, right, which number goes with 1? 18. 18 times 1 is 18. What number would be in the middle? Negative 17. You have to have a negative in the middle. None of these other pairs, none of those other choices create a negative in the center. You have to look at that sign to determine which ones to cross out. So again, just quick process of elimination. Figure out who has to go with that choice, and then see if you would make the negative in the middle. There's only going to be one choice that works, right? I'm not giving you a multiple choice question with 2 or 3 different answers that are right. Only one answer is correct. So, write out the pairs and then make a determination. All right, so question 3. Again, it's the first time I've asked this directly like this. This is how it'll be on the test. I asked you to make a type 2 trinomial. What does that mean? 1 in front of the x squared 3 terms. And I said that the signs had to be different and that the last number has to be 15. And I want it to not factor. So if the signs are different, that's not a plus, right? You have to have a negative 15 if the signs are different. Now, you could do plus minus, or you could do minus plus, whatever you want. Maybe you want to put a plus here. Who cares? I know the signs are going to be different. Okay. So in my case, I just put plus minus. Now, you should list the pairs for 15. There's only 2 of them. 15 is not divisible by 2. It's not divisible by 4 or 6 or 7. You don't go bigger than that, right? You only go up to half of the number. Half of this is 7.5. So It's 15 is not going to be divisible by 9 or 10 or 11. You can't divide it by anything larger than half of it. And, since it's odd, the best you could do would be 7. So you look at these pairs, and I know the signs are different. So I subtract those pairs. 5 minus 3 is 2. 15 minus 1 is 14. So as long as the middle number is not one of these two, it is going to fail. So pick a number, whatever number you want, as long as it's not one of these. Here, put a 7 there. How do you make 7? If you pick 15 and 1, you can only make a 14. If you pick 5 and 3, you can only make a 2. So as long as you put a number in the middle that is different from 14 and 2, pow, that doesn't factor. I just built one that I know does not factor. And I know because I listed the pairs and I saw that 14 and 2 were the only numbers that I could get in the middle. So as long as I pick something different, there you go. Now, if you want to put a minus there, minus 7. You could have did this. I mean, as long as you don't pick a 2 or a 14, any number in the middle that's not 2 and 14 will fail to factor. That's the point. Okay, now 4. I can do them both pretty quickly, so I'm going to do both 4, A and B. These are true, false, just real simple. Is this one a difference of squares? Is this a perfect square? And is this the difference of perfect squares? Now, when you look at it real quick, your instinct is to say true. This is definitely a perfect square. The first number is a perfect square. The last number is a perfect square. But if you were to try to factor it with what I taught you, right? You put 2x and 2x, you put 3 and 3. Now, remember what I told you. The signs in a perfect square are the same. You build a copy. You don't make the signs different. That's the difference of perfect squares. So you'd have to put a negative here. But a negative times a negative is a positive. This should be a plus 9. So the answer to A is false. As long as that last number is negative, that means that the signs were different. But a perfect square is something times itself with the same sign. So this is false. This is not a perfect square polynomial because the last number is not positive. Very tricky. It really looks like it is, but it isn't. In fact, that one doesn't even factor. Now this one, difference of perfect squares. You'd say, oh man, I got this shit all day. This is true. It's true. It is a difference of squares. No, it's not, because 4 times 4 is not 16x. 4 times 4 is 16, but not 16x. This is false also. What type is it? It is the greatest common factor. They have an x in common. Oh, I guarantee you will see this on your test. Make sure you factor it right. I know people will just put x plus 4, x minus 4. That is not factored correctly. This is. So it's false. It is GCF. So this is false, doesn't factor at all. The last number is not positive, so it's not a perfect square. This one has a GCF, so it's not the difference of perfect squares. Now it is. If I took away that x, it would be. It would be x plus 4, x minus 4. Okay, 5, I asked you to do D, E, G. Seems strange. You can do them some of them I could do quick. 5D is a perfect square. The first number is a perfect square, 25. The last number is a perfect square, 9. And it's positive. This is important. This has to be plus or it doesn't work. So you're going to put 5x and 5x. Why? Because it must be something times itself to make 25. To make 9y squared, you need 3y and 3y. Why? Something times itself. Now, what are the signs? They're identical. They're both negative. Pow. That's simple. Don't do anything else. There's no work to show. You just build it. You trust that the middle comes out, and it will. Look, you get 3 times 5, right? It's negative. Negative 3 times 5 is negative 15. You get xy. You get it again on the other side. Negative 15 and negative 15 would make negative 30. So you don't have to check this. I'm just showing you that it works. You do get the 30 in the middle. Now, 5e looks tricky. It is a trinomial. It is certainly not type 2. There's no 1 in front, and this is not, a squared. They all have letters and numbers in common. And if you look closely, 4, 6, and 2, you can divide them all by 2. And then you have A3, A4, A2. Now remember what I said. How do you do the greatest common factor? The numbers, it's easy. You're looking for the largest number that divides them all. There's no larger number that divides 2. The only number that divides 2 is 2. So that's easy, right? 4 and 6, this is divisible by 4, but that's not. This is divisible by 3, but that's not, and that's not. So it has to be 2. So with the letters, you take the smallest power that you see of a letter they have in common. If one of these was missing an A, you wouldn't be able to factor it out into the front. So the GCF is going to be 2a squared b squared, which coincidentally is the dude at the end. Now, this is very important. You are starting off with 1, 2, 3 terms. So inside these parentheses, you better have 1, 2, 3 terms. I'm going to divide them all. Just to show you, I'll write it. It's a pain to write it down, but if it helps you get it correct, I am all for you doing that. 4 divided by 2 is 2. A3 over A2, you subtract the powers, you get A1. B4, B2, subtract them, you get B2. Plus 6 divided by 2 is 3. A4, A2, subtract them, you get A2. B5, B2, subtract them, you get B3. 2 divided by 2 is 1. A squared's crossed out, B squared's crossed out. 1, 2, 3 things. The mistake I see students make, you guys know, a lot of you did it in class when I gave you that problem. You did this. But if you multiply that out, would you get back to what you started with? No, you most certainly would not. So you have to make sure that the -1 is there. Remember, 2 divided by 2 is 1. So you need that there. GCF in the front, 3 terms. Last one, absolutely trivial. Don't try to get cute with this. Don't try to reverse this and flip this. I'm going to write this one first. It's not the same. You can't go 16m squared minus 81. Why? This is positive 81. That's not. This is negative 16. That's not. You cannot reverse it. You're going to do it wrong. This is not how it works. Something times itself to make 81. 9. Something times itself to make 16. 8 and 2. It's not 8 and 2. 4m. 4 times 4 is 16. 1 gets the plus, 1 gets the minus. I want to put the minus first. Then put the minus first. Who gives a damn? As long as they're different, it doesn't matter which one you put first. You want to put the plus first? Put the damn plus first. Just make sure they're different. So remember how similar these are. The perfect square has a copy with the same sign, right? Look, same thing, 5x, 3y, 3y. The difference of perfect squares has the same numbers, right? 9, 9, 4m, 4m, but the signs are different. That's how you tell them apart. Binomial, trinomial, all right? You'll see them all in your test. You'll have to factor them. All right, question 6. Now, question 5 had the factoring 1, 2, 3, 4. GCF, trinomial, difference of squares, and perfect squares. The first 4 types of factoring. Question 6, I separated from the other types because it's a different special type. This is the one where they all have a GCF. They are mixed factoring. So you look for what they have in common and you remove it. Now, you might look at the first one and say, there's nothing in common. It's a difference of squares. 8x, 8x, 4y, 4y. But that right off the bat should tell you something's going on. If you pick 8, 8, 4, 4, isn't 8 and 4 divisible by 4? So there is a common factor. The letters aren't in common, yes. But if you look at 16 and 64, these are both, first of all, they're both divisible by 4, right? Look at the numbers that divide 16. What divides 16? 2, 4, 8. Nothing bigger, right? Cut 16 in half. What's half of 16? 8. So the largest number that divides 16 is 8. Nothing bigger than 8 is going to divide 16. I mean, hello. Now, check to see if they divide into 64. 64 is definitely divisible by 2 and 4. Is it divisible by 8? Hell yeah. 8 times 8 is 64. So you're going to divide away. Damn, I wish I was here in the class because I would have stopped. I would be hoping someone would stop me. Did I pick them all? Right? I mean, I'm telling you that nothing larger than 8 divides 16. I'm hoping someone was watching and screaming, no, there is another number. But the problem is you may not spot that. So remember, you cut the number in half, but what else divides 16 besides 1? It's the hidden one. Never forget the number itself. Never forget that, right? There is always a bigger number, which is itself. So you can't forget to check that. So it's not 8. 16 actually is divisible by 64 is actually divisible by 16 also. So it can be tricky to spot. So, and I'll be blunt with you. I don't want to fool you. So on your test, you're going to see something like this. Big super secret hint. I give you ones that it's a lot easier to spot. I'm hoping it's much easier for you to realize that 36 is divisible by 9 and 36 is divisible by 4. So here, this one you would factor out a 9. Here you'd factor out a 4. It's kind of tough to spot that, 64 is divisible by 16. You're not supposed to know the multiplication table for 16, right? Usually don't. 16, 32, 48, 64. I mean, usually I expect you not to go that high. I expect you to know 36 is divisible by 9 and it's divisible by 4. It's also wouldn't be unreasonable for me, to do something like this to you on the test, to put 25 and 100. This is a practice test. I'll be honest. It's 64 and 16. I'm a little iffy on. I'd rather this had been a 4. But, this is the one that I put there. So you got to be real careful with it. So, yes, 16 in this case is your GCF. They don't have the letters in common. So I'm going to divide them each by 16. Put that in the front, right? This is step 1. You factor out the greatest common factor. So you put 16 in the front. 64 divided by 16 is 4. 16 divided by 16 is 1. And the y squared is left over. Now remember, you're not done. This continues to factor. This is the difference of squares. So 2x and 2x, and then y and y. One dude gets the plus, one dude gets the minus. So remember, it's always 2 steps. You must make sure you show me both steps. If all you gave me was this, I'm marking it wrong. How do you justify that? You have to show me how you got here. And you only get here if you did that step ahead of it. So now, in the next one, I mean, come on. You have 5, 10, 15. There's no trickery here. The largest number that divides them all is 5. Because the only numbers that divide 5 are 1 and 5. 5 is not divisible by anything else except for itself. Everything's divisible by 1. So here it's going to be 5. Now look at the letters. Whoops. I don't like that 5. Do it again. You have x2, x1, none. They don't have x in common. X is not in all of them, so you can't do x. But you have y5, y5, y5. I mean, hello. I threw the same damn letter in all of them. I didn't even change the powers. I mean, if you see y to the 5th in all 3 of them, that's got to come out. So now let's be a little more sophisticated. We're going to put the y5 in front, and I'm going to put the times. 5 divided by 5 is 1. X squared is going to stay. And I lost my y5. Take away. 10 divided by 5 is 2. The x is going to stay. I lost my y5. Minus 15 divided by 5 is 3. And the y5 is history. That's step 1. Figure out the GCF, remove it to the front. Step 2 is to look what's in the parentheses and continue to factor it. How do you do that? That's the same shit we did before. Put the 2 parentheses down. Put x and x. Do the signs. This one goes first. They're different because this is a negative. Now, what are the choices? You have a 3. It's 1 and 3 for sure. Now, I don't want to see that. I taught you that the larger number has to go first. Now, how will I know that you didn't do this with the method I taught you in class? You'll write this down. Instead of writing x minus 3x plus 1, you'll write x plus 1. It's the same thing. And it is the same thing, but it shows me that you ignore me. It shows me that you don't drop the middle sign, like I showed you, and that you put the larger number there, and then figure out the other sign. What this shows me is that you completely disregarded the technique that I taught you. I mean, depends on how I'm grading and what else you wrote, whether I would deduct any points for that. I probably would not, but at least I would know that you don't listen to anything that I say and you just do whatever the hell you want to do. So that's not necessarily a good thing. All right, at last, we have reached number 7. Now, the first two, 7A and 7B, they're on your test or on your final. They're the two that the solvers don't do right. That's bullshit. They do them right. They don't. The solver does not do this one by factoring. It never will. It will always use a different property that you don't learn in this course. The solver also does the first one wrong. The solver will divide away a number, and you can't do that. The first one, 7A, is GCF, greatest common factor. The solvers don't factor it right. So as soon as I see you get these wrong, I know that you use it. I know for a fact there's people in the class doing it. So, don't be stupid and don't do it, because I will know that you did it. I'll know by everything else that you wrote and your other answers, especially that, if you can't do the one where I tell you to tell me the signs and the pairs and all this stuff, then I know, that you cheated. So the first step of this is to set it equal to 0. It's not equal to 0. So you have to take this and do the opposite of what you see. Remember, you have to get a 0 here. So if you see a negative 12, you have to do a plus 12. But if you do it to that side, you have to do it to the other side. And you have to make sure you put it in the right place. I didn't leave myself enough room here. So you're going to do 20x squared plus 12x. That's the first step. Set it equal to 0. This one's already equal to 0. You don't need to do that on the second one, but you need to do it on this one. Now, step 2 tells you factor it. I'm looking for the largest number that divides 20 and 12. 12 is divisible by 2, so is 20. 3, no. 4, yes. 6, but 20 is not divisible by 6. 12 is divisible by 12, but 20 isn't. So you're going to factor out a 4. What else is in common? X1, X2. You're going to factor out 4x. So again, if you want to put it underneath, put it underneath if it helps you. 20 divided by 4 is 5. X2 over x is x. Plus 12 divided by 4 is 3. The x's cross out. Equals 0. What happens if the equals 0 is not there? I'm done. How are you going to do more without this? Quite a few of you, I noticed on that classwork, you didn't put the equals 0 when you factored. So if you're about to say the product of two things is 0, therefore one of them must be 0. I mean, if this isn't here, how the hell did you do this? Where did this come from? You must make sure it's there. Now, people forget it, and I know they do. So, if you forget it once, that one's on me. But if you forget it each and every time, at some point I have to start deducting points for that, because it is a mistake. And you have to make sure that it's there. If the product of two things is 0, one of them must be 0. Now, to solve this, right, this is 4 times x. You divide by 4. 0 divided by 4 is 0. Here you subtract the 3 first, and then you divide by the 5. Now, I know you're all going to show me that work, except for Kazi, who never does any of this. Or he'll do it all in his head. So those are the two answers that you get. You are not allowed to jump to here. Not at this level. Every step of the work must be there, or I will take points off. Okay, so set it equal to 0, factor it. This was the step 3, right? I didn't call it step 3, but set equal to 0, factor it, set each of the factors equal to 0 separately, and solve them. You're going to play the same game here, although it's already equal to 0. So you can just jump right in and factor it. 6x times 6x makes 36. And then 11 times 11 makes 121. As long as the signs are different, it doesn't matter. Now set each, right, equals 0. Set each one equal to 0. Why? Because if you multiply two things and make 0, one of them must have been 0. That's the 0 factor property, or 0 product property, whatever you want to call it. Subtract 11. You get 6x equals negative 11. Divide by 6. Right? Cross them out. Same thing here. Add 11. Get 6x equals 11. Divide by 6, cross them out, right? You cross out. This is what we used to do. We solved before. There you go. You get plus 11 over 6, minus 11 over 6. I told you that if you want, you could write plus or minus 11 over 6. But to be honest with you, I prefer you write that. All right? And it's not a lot of work. This is not a lot of work. But it is work, and I need to see it. So make sure that it's there on your test. One more to do. All right, so the last problem's in 7. I decided to do a bonus one, since I know you're going to have one like 7D on your test as well. They're both very similar. They're both trinomials. They're both not equal to 0. This one, you have to get rid of these two. Do not, under any circumstances, move the x squared. If it's positive, you leave it the hell alone. You leave it where it is. You move everybody else to his side. So remember, you have to switch them when you move them over. So you have to subtract 10x. You had a plus, you have to minus it to make a 0, right, to cross them out. You had a negative 24, you have to add a 24 to cross them out and make a 0. Right? So remember, you're switching the signs. This is what crosses them out and puts a 0 here. Now, this is the same thing we've done a million times. You put the signs, you put the pairs. You put x and x. The signs are the same. How do I know? Because the last number is positive. Drop that sign. So now you got to look at the pairs. I'm not going to write them all down. 12 and 2 make 10. But they only make 10 when you subtract them. And my signs are the same. So I'd have to add 12 and 2, and that makes 14. So this pair would not work. But if you take 6 and 4 and add them together, you make 10. So that's going to be your pair. Right? You're adding the pairs here because the signs are the same. So if the product of two things is 0, then one of them must be 0. So set each of the factors equal to 0. And then, do the ridiculously moronic baby step. Add the numbers over to the other side. Pa-pow. X was 6 or X was 4. You always get two answers, right? X squared equations have two answers in them. So really easy, equal to 0. Now this one is a reason I picked this one because I've seen a lot of people massacre this problem. You have to do plus 5x to get rid of the minus 5x, right? So here's what I saw people do. This is bad. We write x2, x1, none, right? The powers go in descending order. 2, 1, none. You don't write 2, none, 1. That's not the game. I need to put this plus 5x here, where it's supposed to go. If I see you put it in the wrong place, even if by some miracle you factor it correctly, I'm marking it wrong. Because then you're showing me you don't understand the correct way to do it, or that you use the solver, because the solver don't give a shit what order you put it in. The solver will factor this, right? If you put this in the solver, I guarantee you it's going to factor it correctly. So as soon as I see that, you either don't know what you're doing, or you cheated. So one of those two things, and I don't tolerate either one of them. It's a little better if you don't know what you're doing, but you should, since I've been teaching you all this time, as long as you've been listening to me. So add the 5x, put it in the middle where it belongs. Correct form. x2, x1, none. Don't put it anywhere else. Now, I have to do my signs. I know this sign's going to go first, and I know this one has to be the opposite of, they have to be different because I have a negative here. So 36 has a lot of pairs. 36 is divisible by 1, 2, 3, 4, and 6, not 5. 36 not divisible by 5. So it's got a lot of pairs. So you might have to think for a little while. I don't mind writing them. That's not going to make 5. That's not going to make 5. That's not going to make 5. Right? What's the other pair? 4. Oh, that makes 5, right? You subtract them. The signs are different. So it's going to be plus 9 and minus 4. And if the product of two things is 0, remember, you're not just factoring. You are solving for x. So either x plus 9 must be equal to 0, or x minus 4 must be equal to 0. So here you're going to subtract the 9. Sorry, it's sloppy. And here you're going to add the 4. So you get x is negative 9, and you get x is 4. Those are the two answers. All right, so again, set it equal to 0, factor it. Set each factor equal to 0 separately. Make sure the equal 0 is here, or you cannot justify this step. I mean, how are you going to pull them apart and set them equal to 0 if that's not there? This is missing. This is not an equation. There's nothing to solve here. This is just, what do? You would stop there, right? Like on all the other questions. Think about question 5 and 6. Did you do this? No. You factored and you stopped because they weren't equations. These are equations. They have an equal in them. So you have to make sure that that equal 0 stays there the whole time, or you can't get these answers otherwise. All right, so at this point, all I can do is just wish you luck. Hopefully you guys will watch and you'll do the sheets, you'll do the problems. You should do them all. Obviously, I couldn't do all the ones on the sheet. I'm lucky I even found the time to do this. So anyway, good luck.